Hi everyone, this is Sidi Naajee, and I am going to try to show you, how you add vectors. Okay, so first of all, what in the world is a vector? A vector is just a segment that has a direction, and it usually is represented by some letter with a little arrow on top of it that always points toward the right here. And the arrow is representing, for example, let's say if we're talking about force vector, it's representing the strength of the force, and in this case, the direction is toward, the right. If, on the other hand, let's say I am representing another force vector, or another, let's say a velocity, for example, then in that case, you're representing it with a red arrow right here. Again, the length of it is what we call the magnitude of the vector. And of course, always you have some label for it. Now, a vector is still a vector, the same kind of vector, irrespective of where you draw it, as long as you maintain the same magnitude and the same direction. So, in this case, for example, if we want to add these two vectors, there are two different methods. You could add them successively, okay, when you are trying to represent successive, successive events, or you could add them simultaneously. So if you add them in a sequence, that's what people usually would refer to as the tip-to-tail method. If, on the other hand, you're adding them at the same time simultaneously, then you would refer to that as the parallelogram method. So I'm going to show you first the tip-to-tail method. So this is tip-to-tail method of adding what? Of adding vectors. So here we go. What you do is you take this here. Notice here how this is how big it is, but I am using this just so I would maintain the direction the same way. Okay? And then at the very bottom here, I am going to go ahead and draw the vector right there until I get the length that I want. Now, this should be comparable to that, as you may see right there. And then this is, for all reasons or for all purposes, this is my vector B. Now, here's the deal. These are successive events. So, for example, you imagine I would displace myself by a value A, and then I displace myself by a value B. And I'm trying to figure out what's the total displacement of my body, okay, for example. I'm just giving out an example. So in this case, when you add those two, you are going to end up, let's choose purple here for that. I don't know why, but here we go. So what you do then is you go from the beginning of your first vector, and you go to the last or to the end of your second vector, and you would be able, or actually I missed a little bit the mark here, big time, bad notch. So here's the deal. Again, one more time, you go from the beginning of the first one to the end of the last one, because these are successive, kind of aspects. So in this case, this vector here is representing my A plus B. And in this case, I am using the tip-to-tail method, as you can see right there. Cool. Say cool. Now, at this point, I am going to go to the next slide, and I'm going to show you these same vectors, but I'm going to add them now simultaneously, or using what we call the parallelogram method. So here we go. Let's do that. So again, I am going to make sure that I have a grid, so I would be able to do things in a reasonable way. And then after that, I was smart. I already copied this, so I'm just going to paste the original two vectors. Here we go. Notice, here they are, just as they were in the earlier one. But this time around, instead of me adding this at the end of this, that's why tip to tail, I'm matching the tip and the tail of each one of my vectors. Instead of doing that, no. This is what I'm going to be doing. I'm going to slide this, and I'm going to bring it to the beginning of the very first one. So both of them would seem as if they are originating from the same point. So in this case, I am going to do that. I hope the length is the same. I hope the direction is the same. Now, technically, I should be able to figure out the angle from the horizontal here, the angle from the horizontal here. They should be matching. These both should be theta, as you can see there. Okay? Now, let's hope the length of this, so here we go, about this. Oh, I overshot that, so it's really not quite as, and also the angle is not perfect either. Well, here we go. And I'm showing you how I would do it, within a reasonable plus or minus. So, in this case here, this is my B. So the question then that would arise is, how do you get to add these two using, the idea of the parallelogram method? Well, the suggestion is that you have a parallelogram. Therefore, I am going to have a parallelogram. That means this. Whoa, I don't know what my thingy is doing. So I'm supposed to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's unusual. I usually like to have prime number type of stuff. 2, 4, 6, 8, 10, 12, 14. So that means I have to go right there. So this is part of my parallelogram. Notice this one here is going to match with this red one. So this matches with the dark blue. This matches with that. Both of these are drawn. You don't have to draw them solid. But what matters though, now you're emanating, again, starting from the beginning of the first one, you're going to there's no end one. Instead, you just are going to draw the diagonal from here to the end of your parallelogram right there. And you draw that, and that, my friends, is representing your A plus B. If you don't believe me, you could just go back and see that they are almost within plus or minus matching. Okay? And they should be exactly the same. I mean, it would be only a reflection of your inaccuracy in terms of drawing. Thank you. Oh, again, before we close up, this is what people call the parallelogram. Parallelogram. Don't laugh at me in terms of spelling. Bad Nadj. I think this is only one L right there. Parallelogram method. Oh my God, made a fool out of myself. Don't know how to spell. Anyway, thank you.